Now let's consider the last question there. Now from the question we are given, we are asked to what? Show that the absolute of what? Exponential minus JW will be equal to what? 1. So our question we're given to what? Show that the absolute of what? Exponential minus JW will be equal to what? 1, right? Now what are the parameters here? These are exponential, this is our imaginary part, and this is called what? Your angular what? Velocity. Are we together? And they said when you take the absolute of this will be what? Equal to 1. Now how do you solve this particular question? Remember, this is not a question that you were given to apply the concept of DTFT to get a DTS what? Signal, right? We're asked to what? To show that what we have here will be equal to what? 1. Now how do you do that? The first thing you do is to recall an equation that is similar to what you have here, because what you are expected to do is to simplify this such that when you simplify and you apply the absolute of this value, you arrive at what? 1. That's what you do. Now recall that when we are talking about Euler's method, let's recall Euler's method. And what's the concept behind Euler's method? Euler's method simply says what? Exponential j theta will be equal to what? Cos theta, right? Cos theta plus j sine what? Sine theta. Now, why are we recalling this concept? We are recalling the Euler's method because what we have here is what? A similar concept or a similar what? Parameter with what we have here. So in essence, we are simply seeing what? J theta. In this case, we are seeing j theta, which is imaginary part multiplied by what? Your theta. But on this case, we are now seeing what? Imaginary part multiplied by what? Angular what? Velocity. Are we together? So in essence, we can say that what? Theta here will be equal to what? Minus what? W. In essence, we are saying anywhere we see theta, we are putting what? JW. Now if you impute theta to be what? Minus W into your Euler's method, you now have your new Euler's method equation to be what? Minus JW, which is what we have here, will now be equal to cos, in place of theta now, we are now using what? Minus W, not what? Theta. So we have minus W plus what? J sine what? Minus what? W. Are we together? Now, what we are seeing here is we are seeing what we call your real part and your what? Your what? Imaginary what? Part. So you can differentiate your real part from your what? Imaginary part. What are we seeing here? We are seeing what? A trig function which says what? Cos minus W, and another trig function which says what? Sine minus W. Now recall, when we are talking about the even slash the odd properties of trig function, recall that when we are talking about odd slash what? Even properties of our trig function, we have that when we are considering your cos, if you have cos minus theta, this will be equal to what? Cos what? Theta. But if you have sine minus theta, this will be equal to what? Minus sine what? Theta. Now this is what? The property of what? Trig function. This is what? The property of what? Trig function. So in essence, in place of what? Theta, we are using what? We'll be using what? W to represent. But cos what? Cos minus W will now be equal to what? Cos W, not theta in this case. But when you're now considering sine, you now have that what? Sine minus W will now be equal to what? Minus sine W. Are we together? So what we are trying to do is we are trying to simplify what we have here to the lowest what? Term. So since we have cos minus W to be equal to what? Cos W, and sine minus W to be equal to what? Minus sine W, we are replacing this to our given question for what? Euler's method. So you now have your new Euler's equation to now be what? Exponential minus JW will now be equal to, in place of cos minus W, which is what we have here. So in place of cos minus W, we are imputing cos minus W with what? Cos W. So we have this to be cos W plus, right? That was the equation. So this is what we have plus here. Now we are now having plus J, right? So we have plus what? Plus J into, what do we have here? Sine minus W. And what's the trig property function of sine minus W? We've already gotten the trig property function for sine minus W to be what? Minus sine W. So what we have here will now be what? Minus what? Sine W. Are we together? Now, looking at our question, is it simplified? No, it's not simplified. Why? It's because we are having plus here, and we're also having minus here, right? So we have plus times minus, it is what? Minus. So if you simplify further, you simply have this to be what? Cos what? W minus J sine what? W. Now we can now see our new change for what? Our real part and what? Our what? Imaginary part. Where for your real part, you simply have this to be what? Cos W. And for your imaginary part, you simply have what? Minus sine what? W. Are we together? So from your given question, you've been able to identify your real part and your what? Imaginary part. Are we together? Remember, we can call this we can call our real part to be what? A, and we can call our imaginary part to be what? B, right? Making your Euler's method to be what? Exponential minus JW will now be equal to A plus what? JB. Are we together? A plus what? JB. Are we together? Now recall that when you are to apply, if we are to get, remember our question is to get what? The absolute value of what we have here, right? The absolute value of what we have here is simply what? The magnitude of exponential minus JW. And they said when we get the exponent, if we apply the magnitude of exponential minus JW, that will be equal to what? 1. Are we together? If we have represented our real part to be what? A, and also represented our imaginary part to be what? B, right? If we are to apply the magnitude, if we are to find the magnitude of our Euler's method, you will simply have the magnitude for your Euler's method, which is JW, will be equal to what? Remember, when we are considering magnitude, then we are applying the concept of what? Square root and what? Square. I come again. When we are to find magnitude, what do you do to the right side, the right hand side of your equation? Is to apply the concept of what? Square root and square. What do I mean? From what we have here, this will be simply be what? We are simply going to get the squares of what? A, and also the squares of what? B. Are we together? This is the concept of what? Magnitude identification. This is the concept of what? Magnitude, right? But what we have there, we used what? We used A and B to represent what? Cos and sine, right? So from what we have here, if we represent these symbols, we can represent A, which is our real part, to be cos W, and we also have our imaginary part, which is B, to be what? Minus sine W. So in place of A and B, we can represent A and B as what? Cos W and what? Minus what? Sine W. So we simply have that the magnitude of our Euler's method, which is minus JW, will now be equal to the square root of what? What is that A? Remember, A is what? Cos W, right? All square plus minus sine what? Sine W, also all square. And we are taking what? The square root. Now looking at what you have here, this is telling you that you are simply getting what? The magnitude of your given what? Your given what? Your given values for what? A and B, which is what? Cos W and what? Sine Are we together? Now remember, your interest is to get what is what? cos W all square plus what? Minus sin W all square. Now what is cos W all square? If you punch your if we are to get cos W all square, this will simply be what? The square root of what's cos W all square? Cos W all square is cos W multiplied by what? Cos W. Are we together? And that will give you what? Cos square W. And this will be, remember, your minus sign is going to go because of this square, because you now have minus sin W times minus sin W. Minus times minus is what? Plus. And that will give you, this will now be what? Plus sine square W. This is what you have. Now remember, you are seeing what? Cos square W and what? Sine square what? W. When we talk about trig function identification, we know that when we are to consider the fundamental functions of trigonometry, we'll simply have, if we have cos what? Square theta plus what? Sine square theta, this will be equal to what? 1. So if you are to apply this concept here, you simply have that cos what? Square W plus what? Sine square W will be equal to what? 1. So what you have here will be equal to what? 1. So if you take your Euler's method, which is the magnitude, if you are taking the magnitude of your Euler's method, which is minus JW, this will be what? Square root of what? 1. Because we know that from what we have here, from our trig function, cos square W plus what? Sine square W is equal to 1. Are we together? So we are imputing 1 in this equation here. So since we've imputed 1 here, we'll now have that the square root of 1 will now be what? If you take the square root of 1, this will be what? Equal to what? 1. And that will be the magnitude of your Euler's method, which is exponential minus JW. Now you can see that you've already proven, or you've shown them, that what you have here as your question, which was given, that what showed that the absolute of what? Exponential minus JW is now equal to what? 1, with your following step given. Are we together?